Այսօր մեր հյուրն է Դավիթ Գևորգյան, ինքը Ամերիկայում է բնակվում, ինքը աշխատում է հայտնի eHarmony սերվիսում, որը որ զբաղվում է matchmaking-ով, այսինքն երևի ամենաուժեղ matchmaking սայթն աշխարհում, ու իրանք օգտագործում են շատ հզոր համակարգեր ու շատ հզոր տեխնոլոգիաներ կապված data science-ի, big data-ի, Hadoop-ի ու ընդհանրապես machine learning-ի հետ կապված, ու Դավիթը կներկայացնի ոնց է իրանք դա անում, ինչպես է իրանց մոտավորները աշխատում, ինչերի են հասնում, ինչն են խնդիրները, ու դրանից հետո մենք հարց ու պատասխան կլինի, ու այսքանով կավարտենք։ Դե խոսափոր տանք Դավիթին, ինքը
Իվանեն պրեզենտացիան կլինի ուրեմն անգլերեն, հարց պատասխանն կլինի, երբ որ Դավիթը կվերջացնի դրանից հետո, որտեղ այս նոր համակարգը մենք ենք իրան նոր սովորում, այս GoToMeeting-ը իրան անգլիացով կրկամեն ջան։
Դավիթ ջան, լսում եք։
Շատ լավ, դե սկսենք։ Շնորհակալ եմ բոլորիդ այստեղ գալու համար։ Ցավոք չեմ տեսնում, քանի հոգի են ներկայացել։ Հուսով եմ ձեր ուրբաթ երեկոն արդարացված կլինի եւ շատ չեք զանզանա։ Ուրեմն նախ առաջ շնորհակալություն եմ ուզում խնդրել ամերիկյան համալսարանին եւ data science team-ին Վազգենի հապետի գլխավորությամբ, որ այս իրադարձությունը կազմակերպել են եւ իրականում շատ հետաքրքիր ասպարեզ է եւ կարեւոր է որպեսզի Հայաստանում այս տիպի միջոցառումներ շատ լինեն, meet-up խմբեր եւ իհարկե ամերիկյան համալսարանի կոմպյուտերային գիտությունների բաժնի ղեկավարությանը Արամ Հաջյանի գլխավորությամբ, որ հովանավորել են այս meet-up-ը Դե ինչպես հապետը ասաց, ես կխոսեմ հիմնականում անգլերեն լեզվով, բայց վերջում երբ որ հարցեր կունենա, կարող եք թե անգլերեն, թե հայերեն հարցեր տալ։ Շատ լավ, դե ինչ, սկսենք։ Okay, so I'm David. If you have any questions which I wasn't able to answer, you can tweet them to me using my Twitter token. Or if you want to connect, we can do it through LinkedIn. Here is my LinkedIn profile information. So I graduated from State Engineering University of Armenia. I got my bachelor's degree from there. And I also studied at Lycos Armenia courses. Many of you probably remember those some time ago. I got my master's degree from American University of Armenia in 2008. And this is not Photoshop. It's actually the proof of my graduation. Okay, so what is big data? Let's go over what big data is, a little bit about terminology of big data and data science, and at the second portion of the presentation, I'll try to go over what eHarmony is, what we're doing, and how we're leveraging data science and big data tools in order to accomplish our goals. So is big data a fashionable term? Because I think it is, because most of the time people just refer to big data as in terms of volume of the data. However, it's not just that, and let's try to cover that. So 80% of the data that is currently existing in any enterprise or organization is unstructured data. And some of the types of data that we currently have is structured data, data that resides in relational database systems, data warehousing systems. We have semi-structured data such as RSS, XML, or JSON, which has a formal structure. However, it doesn't conform to normalized forms of relational database. And we have unstructured data, data such as video, audio, any GPS coordinates that you are pushed from your mobile devices, any blog posts, emails, content shared on the social network sites such as Facebook, Twitter, and many others, and click streams. And the last one is super important to note, because almost all of the companies currently are tracking all of the activity on their website. Any type of clicks you do, any type of hovering you do on different portions of their website is actually tracked and is used in order to target advertisements for you. So 90% of the data in the world today has been created in the last 2 years alone, which is amazing, right? So here is an infographic which I found from Intel, which shows what is happening in an internet minute. And as you can see, about 350,000 tweets are being generated through each and every minute in average. About 3.3 million pieces of content are shared through Facebook. And this is probably a year old or year and a half old infographic. It's probably much more now. About half of the traffic generated on the internet is through Netflix and YouTube in terms of videos. And the future is actually staggering. In 2017, there will be 3 times more mobile devices than people on Earth. And we can even see that today. We have computers, we have mobile phones, we have iPads, we have smartwatches, and other tools, which are all generating data constantly. The data that has been created in 2013 alone has been about 4 zettabytes, which is 4 million terabytes. It's an amazing number. And we need to have tools and systems and infrastructures to be able to process all this data and come up with insight. And that's what data science is about. So here are some properties of big data. And big data is characterized by volume, the amount of data that is generated, by velocity, the speed at which it is generated. And as we saw in the previous slide, the speed of data generation is amazing. The variety of devices that are generating the data through sensors, video, audio, social, email, and veracity, the authenticity and the accuracy of the data. And the last one is super important because you as a data scientist or you as an engineer that need to rely on the data need to know how accurate is that data. Can you actually trust the data at all? And so what data scientists do, usually any type of source of the data that they use, they will assign some kind of weight of accuracy, and they will consider that during their modeling. So the solutions that are required in order to deal with this data has enforced us to change the way we're dealing with it, or the solutions have been redefined. So the way we collect the data, transport, store, manage, analyze, and visualize has changed. And as you probably know, there are a lot of different systems which have emerged in order to help us doing that. For example, Flume, which is an Apache project which is used for log collection. Apache Kafka, which is a messaging broker, a distributed messaging broker, which allows you to have very high throughput with low latency for transporting the data. Many NoSQL databases such as MongoDB, Voldemort, Cassandra, which are helping you to store data, and much more. So even though the amount of data we had previously was still large, but the systems that have been out there many years ago weren't available to the general public. With emerging technologies such as Hadoop infrastructure and all the related technologies, we're now able to, as a general public or general population, even as a small company, to leverage all these tools to come up with machine learning models to do predictions. So I did a little bit of search. This is through Google Analytics or Google keyword tools, and I searched for big data term. And as you can see, starting from 2011, the amount of news articles which had big data in their headlines has plummeted. People are talking about big data. People want to know more about big data. And so that's one of the reasons why we're gathered now in Yerevan, and I'm here in the US, and we're discussing this, because this is a super important topic to discuss. And we need to have more expertise, or universities such as American University of Armenia and others in Yerevan in Armenia need to redefine the way they talk about these topics and engage more professionals in this field. So what is data science? We have heard about the term a lot, and most of the people are referring to data science as statistical analysis, which I think it's not only statistical analysis. It is a combination of things. It is a science and kind of an art to explore the unknown about the data. And I was reading an article and I found this phrase which said making discoveries while swimming in the data, and I like the definition of exploration. It's kind of you're doing discoveries in an unknown sphere, and you don't know what you will get out of it. So data science is dealing with refining the results for accuracy to ensure that whatever data they have gathered is actually reliable. Data science is dealing with deriving actionable insight from it, something that can be useful for the business in the future, to be able to predict some things based on the insight and create data-driven products. That's very important, because if you have gathered insight, you have to go and prove as a data scientist to different teams to pitch your opinion, and in order to make sure that eventually you come up with a product that will be helpful for your organization as a whole. So who are data scientists? And this is a quote from Josh Wills, who is a chief data scientist at Cloudera, one of the main contributors to the Hadoop distribution. And he said, data scientist is a person who is better at statistics than any software engineer, and better at software engineering than any statistician. And I really like this definition. But data scientist is not about just statistics and software engineering. Here is a Venn diagram from Drew Conway, post from 2010, which describes that data scientists are people who know math and know statistics in order to be able to derive some insight. They have hacking or computer engineering skills, which allows them to crawl the data, to be able to write programs to define all these statistical models, and which helps them to transform the data. So you need to have computer engineering skills in order to be able to deal with the data. And the last portion is substantive expertise or domain expertise. And, excuse me. And that one is really important, because as a data scientist, if you're dealing with the data, you need to have some kind of domain expertise and be able to correlate it to a particular domain of business or problem. And so that data science is a combination of statistics, computer engineering, as well as business or domain expertise. That's my opinion. And so what are the big data science tools that are available? And there are a variety of them, a bunch of them. And I would like to note here that you as a data scientist do not necessarily need to know all of these tools. You just need to know the tools that work for you, for your particular problem, and just stick to them until it doesn't work and you switch to another one. So you don't have to know all of these technologies in order to be able to deal with data science. But as I said, you need to be able to do some coding. So at eHarmony, we use Scala for model definition creations. We have created a generic library that deals with machine learned model definitions, and I'll go over that in the upcoming slides. We're leveraging Hadoop HDFS MapReduce for our scoring. We use Apache Score for real-time retraining of the data. We use Flume Scoop for transporting or transferring the data. And we use a lot of different NoSQL databases for storing the data. And of course, one of the best tools for visualization is Microsoft Excel. If you have less than, I guess, 80,000 rows or 60,000 rows, then it will work fine. So I did a little bit of search on Indeed.com, which is a career website, on job trends on data science and data scientists. And as you can see, starting from 2011, the amount of jobs that or job listings which include data science or data scientist keyword has plummeted. Companies and organizations are really interested in this field. And that's why, as I said earlier, this is very important that we have this meeting in Armenia to encourage you guys as professionals and experts to be more engaged in this sphere and to drive more innovation in this sphere back home in Armenia. And so what is the eventual goal of data science and big data tools? The goal, of course, is revenue. And you can gain revenue by multiple ways, right? You can gain revenue by improving the customer experience, decreasing the customer churn, and seeing why are the customers leaving to other companies, and being able to bring that knowledge and improve your systems, to increase operational efficiency. And here are a couple of large companies and the ways they're using big data. For example, Generic Electric uses big data and data science to optimize maintenance intervals for industrial products. Previously, they didn't know when exactly it needed it. But now with the use of prediction algorithms, they can actually do it in a more efficient manner. Google, Zynga, Netflix, Kaplan, and eHarmony use big data, and here are a couple of examples. So before I move forward to my next slides, I wanted to give you guys a very interesting story about how data science worked for a particular company in US. So there is a big department store, which is basically a managed Tanhamar in US called Target. And there was this famous case, which is sometimes denoted as Minnesota Dad. And that dad basically went to Target and started to complain to the managers that they were actually giving some advertisements or showing some product advertisement to her daughter for pregnant women. And he was really furious, and he didn't like that a lot. And so the manager apologized and said that they'll take care of that and ensure that doesn't happen anymore. And a month after that, they get a letter from basically the dad saying that his daughter was in fact pregnant. And that's funny, right? Target knew a month prior to the family that the daughter was actually pregnant. And the way they did it is by tracking the activity on the website. She was buying more unscented hygiene products, and hence their machine learned algorithms were able to predict that probably she's pregnant. That's why the rate of use of such products increased. So as you can see, the application of this is enormous. You can use it in any sphere. And another interesting example is not only companies, commercial companies use data science, but also countries. Recently, United States of America appointed previous chief data scientist of LinkedIn as chief data scientist of United States. And they're working on opening country data to the public. They have already completely shared with the public about 100,000 or more documents, which you can, any of you can use in order to do weather predictions or some other things. And I heard that they're creating actually dashboards for the president to look at every morning when he wakes up, which is amazing, right? Not only just companies, but also countries are interested in this sphere. And it's really important that we take care of the advantage and move forward in the sphere. So who are we? So my first quiz of the day would be, how many of you guys have heard about eHarmony previously? And I would like someone, maybe Vazgen, to tell me, because I can see. Percentage-wise, maybe?
It's about 20 people.
Okay, so about 40–50%. Yeah, that's amazing. So let me tell you a little bit a story of matchmaking of eHarmony. And before we do that, I want to go over why traditional methods are not working anymore. This is a study published just recently, which shows that online dating is about 16% of the whole portion of different ways that people meet and as you can see, online dating is more than has more portion like as compared to work, meeting through friends, social networking, school, or social gathering. And the reason for that is primarily people do not have as much time as they did previously to go to these social gatherings. And the other thing is, hopefully I'll go over that in the upcoming slides, and it will be clear that through online dating websites such as eHarmony, we're able to get or gather a lot of psychological profile information about the users, and we can match them in a better way than they would try to do it themselves. So eHarmony was created by Dr. Neil Clark Warren about 15 years ago, and he was working as a clinical psychologist and marriage counselor for about 25 years. He was basically helping couples in their relationships. And after working for 25 years, he realized that there are some things which make some marriages much better than the others. And he came up with 29 dimensions of compatibility, or factors of compatibility, which we leverage until this day. According to a recent study, eHarmony couples describe their relationships as the happiest, most passionate, and most fulfilling. And in past 15 years, we have created almost 650,000 marriages, which is affecting about 1.3 million people, which is amazing, right? If you count the amount of children that will rise from this relationship, it's doing some good work for body rank. Okay, so how do we check the quality? How do we know that these are actually good marriages? And we do that by, there were a couple of different companies independent of eHarmony which did analysis and found out that people who married through eHarmony in the past 15 years, their divorce rate is about 3.8%. Unfortunately, it's not 0%, but it's 3.8%. To compare it with the national average in the United States, the average for the same period of time, for 15 years, would be about 30% or more. So it's 10 times better. And we now are responsible for about 5% of all new US marriages goes through us, which is nice to know. We have about 438 marriages per day. And if you walk around our office, you'll see a lot of pictures which people who got married through eHarmony sent us, thanking us for the work that we do. So it's really encouraging. So what is the difference between eHarmony and all other matchmaking websites? You have probably heard about Match.com, OkCupid, the Tinder, Plenty of Fish, and others. The main difference is the compatibility matching system that we have, which consists of three main stages. Compatibility matching, which is dealing with 29 dimensions of compatibility based on the psychological and personality profile of the users. Affinity matching, which is using machine learned models to do some predictions, such as probability of communication between users. And match distribution, which is ensuring that we deliver as many people, as many matches to as many people as possible. So more people will be happier in the whole eHarmony group. So let's discuss the compatibility matching portion first. The traditional search is unidirectional based on user-defined criteria. And what I mean by that is when, let's say, Nicolette wants to buy a phone, right? She chooses, as in this example, the first and second phones. However, that's as far as it can get. The poor phones do not have any saying in this choice. They can't make a decision or affect the decision. And so Nicolette will buy either the first one, second one, or if she can decide, she will buy probably both of them. However, when you're dealing with matching between people, it is bidirectional because you need to consider preferences both for Nicolette as well as other portion, which is Leo, Ian, and Steve. And you can make matches only in the case when preferences for Nicolette as well as Ian are matching. And some of these preferences are, you want someone within 10 kilometers of where you are. You want someone who is a smoker. You want someone who is not a drinker, or probably you wouldn't want someone who is a smoker, but non-smoker, non-drinker. You want someone within a specific age range, who has a specific religion, etc. So those are some of the things that we consider as a first stage when we filter out all the users. The second stage is considering all the relationship questionnaire answers that they gave. And some of those relationship questionnaire questions would be, how does a specific word generally describe you? For example, how do you think, how warm are you? Or how would your friends would describe you? Would they tell you that you're a good listener, outgoing, kind, respectful, caring? And as you can notice, these are actually important questions. When you meet someone through a bar or outside you just walk with them, you wouldn't ask them, so how good do you behave under stress? That would probably be an unethical question, and that will ruin the whole relationship. But here you actually we ask such questions for you. We can ask those questions and get personality and psychological profile both for the user as well as all the candidates. And then we use that in order to extract things such as how personality factors, value factors, attributes, and belief factors for them. And some of these factors or dimensions are level of humor that you have, level of spirituality that you have, level of intellect, energy, sociability. And this is super important portion because we don't ask them, so what is your level of humor? We ask them some other questions, and then we derive from that what is their level of humor based on those questions, so they can't cheat. And there are 3 full-time psychologists working on this problem just by itself, because it's really important to do this correlation correctly. So once we have done it for both the user here and for the candidates, we run them through a complex mathematical equations and all algorithms and come up with a particular score. And if that score is above a specific threshold, then we will consider them compatible. And the way we have determined that threshold is we basically did a study for 5,000 couples and marital satisfaction study where they were describing how happy they were in their relationships. And we took top 25% and anything, and that's where the threshold is. Basically, if you're better than all the 75% of the users that we did in our study or considered in our study, then we'll consider you to be compatible, which is interesting, right? So just to cover that portion, first step, use and user, is basically we are going to consider you, for you, every user in our use base, tens of millions of users. And then we'll consider user and candidate criteria. As I said, you want someone within specific distance, you want someone within specific age range, etc. And we'll narrow it down to a smaller set. Then we will run them through compatibility models, which are using personality and psychological profile of the users, and we'll narrow it down even more. So the first search is done in MongoDB, and I'll try to cover it and see why we have chosen specifically MongoDB. And the last portion, we will save the residual into Voldemort, which is distributed NoSQL hash map, or distributed hash map if you want to call that. And I'll cover why we have chosen Voldemort as well. So why MongoDB? The initial version of our matching infrastructure was running against Oracle database. And just to give you the scale of increase that we had, in past year, we have created more matches than in all 14 years prior to that combined. So the growth of our number of matches that we deliver on user base is staggering. So we had to do something about it because database team hated us. They didn't want to hear anything related to matching. And so we decided to come up with our own solution. We needed a system that would be able to support about 60 million plus queries per day, would have powerful indexing features, and would be able to support fast multi-attribute searches. And as I said in the prior slides, these multi-attribute searches are, you might have 10 preferences for distance, smoking, religion, age range, height, and other things. And candidates as well. We need to consider all of those when performing the searches. We wanted a system that would be very easy to maintain because our operations team or system administrator team was very small, about 10 people, and we didn't want to put the burden of maintaining this to them. We have been using our Mongo cluster for about 3 years, and we just look at it once in a while and never touch it. So even as an engineer, we were able to maintain the cluster very easily. And our cluster is pretty large cluster. So the wins that we got for free by using MongoDB was automatic scalability. And this term means basically if you have a cluster of 10 machines and you need to increase the capacity, you wouldn't necessarily buy 10 other machines which are more powerful and replace them. You can just add 5 more machines with the same capacity, and it will automatically scale. It has built-in sharding mechanism, and sharding in MongoDB terms is basically the way it divides the data. And it deals with automatic rebalancing of the data, where you as an engineer wouldn't have to touch it. If you add more machines, Mongo will deal with rebalancing of the data and dividing the data. And it also had really nice monitoring and management service, which is a user interface-based solution. And it shows the CPU utilization, network utilization, memory utilization, and other things. And you can actually specify alerts based on those. If your CPU is more than, let's say, 90%, then probably that's a critical alert, and someone needs to look into that. And it helps you to do that. So before I move forward, how many of you guys have heard about Voldemort? And I can't see, so I'll ask Vazgen again to do some moderation for me.
Five people.
Okay, so about, I guess, 10%? Okay, I see. So
I think less.
Okay, less. When you guys, did you think I was talking about this guy? For the lovers of Harry Potter, this is a character from that Lord Voldemort. And the system that I was talking about isn't about this guy. It's probably named after him, but it's a distributed key value store or distributed hash map developed by LinkedIn. And I think outside of LinkedIn, eHarmony is the largest users of Voldemort. We wanted a system which would support billion+ potential matches per day. We wanted a system that would be able to deal with CRUD operations, creation, read, update, and deletion operations very, in a performant manner. And we wanted a system that would be able to support varied transaction sizes. And the last one is interesting to note is because if you're a user and you accept anyone in the world, you're such a loving person and you don't care about any personality preferences or anything, then you will get millions of potential matches. But if you're a person,
Davidjan, we have a connection issue here.
Okay.
Let us reconnect.
Sure.
Connection. Հարցերը վերջում։
Could you repeat your last sentence?
Sure. So did you guys hear about CRUD operations?
No.
Okay. But can you hear me now well?
Yes.
Yes.
Okay, great. So we wanted to have a system which would support billion+ potential matches per day. We wanted a system that would be able to support CRUD operations, creation, read, update, and delete operations. We wanted a system that would be able to support varied transaction sizes, because if you're a person who accepts anyone in the world, and you might potentially get millions of matches, or we'll of course filter it down, but we will have to consider each and every possibility. And we also have users which live in the middle of nowhere, and the only amount of potential matches they have is intense. So we needed to support both of these use cases. Some of the wins by using Voldemort is that it was supporting automatic replication, where, as I said, in the case of MongoDB, it was able to replicate the data across the multiple machines. So if you lost some portion of the cluster, let's say you have 10 machines, you lose 1 or 2 of them even, depending on how you configure your cluster, then it wouldn't affect the functionality of the clients of the cluster. It might affect the performance a little bit, depending on your provisioning, but it wouldn't affect the correctness of the applications. It will deal with automatic partitioning of the data, and you wouldn't have to deal with it at all. And it also supports pluggable serialization. So initial version of our applications were using JSON as a serialization format because it was really readable and it was understandable by machines. But it didn't work very well because, as I said, the amount of matches we create now was much more than we did previously, and we had to reconsider that. So we started to use a serialization format developed by Google, which is called protocol buffers. And the nice thing about it is that it's both backwards and forwards compatible. So if you add fields or you remove fields and you deploy that only to the client or only to the server, your whole system will still work. But if you guys remember Java serialization times, even if you added a new field or removed the field or renamed the field, then you're done. You'll get serialization exceptions because the serialized UUID is not matching and other things. So protocol buffers is a really good serialization format. So, and it is supported out of the box. And it is supported out of the box by Voldemort. So it does support Java serialization, JSON, overall protocol buffers, and just usual strings if you want to. So that was something good. Okay, next let's talk about affinity matching, which is the portion, as I said previously, where we consider the historical data for past 10, 15 years, and we use that in order to predict the probability of communication between users. And here is where we use our data science and big data tools. So the need for that is the following. Imagine you have tens of thousands of potential matches, right? Which are matching based both the user and candidate preferences. They are compatible, but you need some kind of a way to ensure that these people are actually going to talk to each other. And that's where we use data science. And some of the things that might affect probability of communication are the difference between age between the people, the distance in miles, and other things. So in the upcoming slides, I'll try to give you some fun facts on from which we extracted from our data. Some of the facts are, for example, how distance between users matters in probability of communication. As we can see, most of the communication is happening where people are near each other, because that is logical, right? Yeah, you want to give people matches who are near them so they can actually go outside with them, be able to go to a bar, go to a park and talk to each other. But then it decreases as the distance gets lower and lower, or distance gets more and more. However, as you can see, this is actually the distance between East and West Coast. And the communication is getting higher after a certain point. So this is something that you wouldn't be able to just determine without looking at the big data. Now we know that we would be able to give matches people who are in West Coast if the user is in East Coast and vice versa, and it will still work. This is the heat map showing the overall communication happening on eHarmony website. We actually operate in all countries in the world. However, most of the marketing campaigns that we do is in US, Canada, Brazil, UK, as well as Australia. And I would like you to know this graph, and because I'll refer to it in the future. We divide the whole geographic region into 3 different regions. We have Americas, Europe, and Asia. And when we're running our offline Hadoop jobs, we'll run them 3 times per day, because we want to ensure that by the time people wake up in the particular region, let's say in Australia, they get fresh matches. So I'll refer to this in the future. This is a very interesting and fun graph to share. How does the height difference in centimeters between the male and the female matter in communication? As you can see, most of the communication is happening when male is taller than the female by about 10-15 centimeters. And the other fun fact, as you can see here, men are more eager to talk to female who are taller than them, as you can see in here numbers, than female do. And I'm sure my Armenian friends will, male friends will know about that, right? Who doesn't want to date a female who is taller than him? Okay, and some other interesting article that I read in here was, if you want to date a female who is taller than you, then every 15 centimeters that she is taller than you, you have to earn, if you're in US, $20,000 more per year. So you have to be rich if you want to really date a female who is taller than you. Okay. So here are a couple of other interesting insights that we have extracted from our data. If you're a male and you want, or you're a man and you want more communication from a woman's female side, then if you describe yourself perceptive, which is angaloch, physically fit, passionate, intelligent, funny, optimistic, then you will get more communication. On the other hand, if you're a female and you want more communication from a male side, then here are some words which track more communication. If you describe yourself, for example, as sweet, funny, ambitious, thoughtful, easygoing, then you will more male will talk to you. So if any of you guys ever decide to use online matchmaking website, these are some things you should probably consider. And I'll share this on SlideShare, and I'll put the link on Facebook event group, so you'll be able to refer to these slides in the future if you're interested. So all of that was fun part, but let's see how we actually derive all of the data. What are the means that we use in order to gain some insight from the data or obtain some insight? So the data needs for affinity are large. Machine learned models are very data hungry. In our website, we have about 50 million plus registered users, which in total have uploaded more than 250 million photos. And we consider about 1,000 attributes when doing some predictions for them. 1,000 attributes. Can you imagine that? Imagine that you have only a couple of attributes. You need to create the whole graph and be able to trace it through. 1,000 attributes, you as a human being wouldn't be able to even understand what the algorithm is doing. So that's why we have all these machine learned model definitions and this whole sphere of data science to help us to cope with this amount of data and come up with patterns that we as human beings wouldn't be able to define ourselves easily. So in total, all these users have answered about 4 billion questionnaires, and we create tens of millions of matches per day. So how do we do that? One interesting thing, design element that I want to share with you, and I actually designed this portion, any type of activity that is happening on the website is being actually tracked. As I mentioned in the previous slides, where we have click streams, right? Any click that is done on any portion of the website, any view that is being done, depending on how much you hover on the website, in the background you can see the heat map. We're throwing these events into a messaging broker, and there are systems which are actually listening to that. And they're sending it to different other systems, and those ones are doing aggregation of the data. For example, this one, user activity service, is responsible for real-time aggregation of all communication data for the users, and it says that in hourly, daily, and total formats. And you might ask, why are we using Voldemort for that, for keeping historical data? Because we had expertise in Voldemort, and we did a trick there where we use user ID in combination with the full date in order to keep historical data. And we're able to process tens of thousands of events per second, which is much more than we currently have. And it works really fairly well. We use the communication aggregates in different other services, such as user service. And this is an interesting notion here, because you might ask again, like, why aren't we using data from Oracle database? It's got to have all of the user information, right? But again, we have performance issues here. We don't want to hit the database directly. And we have this user service, which is acting as a cache in front of Oracle. And some of the responsibilities of it to gather data from user activity service, from Oracle, from many other teams. And it acts as a all user data truth for matching purposes. We have other events which we're capturing and using in order to refresh data here. And the response times for this is in average 5 milliseconds, which is super good. So how do we actually leverage all of that data? As I said previously, we have all these potential matches. And potential matches are just a combination of IDs. We have user ID and we have candidate ID. So we'll dump all of this data into HDFS. We also have user service, which we covered in the previous slide here. And user service has user ID and all of the user information. We'll dump all of the user information as well to HDFS. We'll use map side joins to join the information from these both sources. And we will, as a result of that, we'll have just user and candidate objects. And we will do some, we'll run MapReduce jobs, which are performing the actual scoring. And the jobs are actually scored through a library that we created, which we will open source very soon. It's called Aloha, and it's very generic library to define machine learned models. And it supports a lot of different structures such as Weka or VW Wobit or some others. The whole process is orchestrated through Spring Batch, and we use Spring Data Hadoop in order to connect to Hadoop and run the Hadoop jobs. And I was one of the main engineers helping Spring Source or VMware guys in order to develop and make it production ready. And besides that, we also leverage Apache Commons VFS, which is a nice technology. If you guys have never heard about that or never used, you should definitely look into that. VFS stands for Virtualized File System. And since we have all these different sources, we want to design our systems in such a way that our software only knows about virtual file system objects. And if you switch from one file system to another, for example, from Amazon S3 to HDFS, you wouldn't have to need to change your code at all. You just change some configuration properties, which is really neat to have. So the first version of the system was running against Amazon Elastic MapReduce, and it was working fine for a while, but then we started to experience some problems. First of all, it was expensive. Second, since you're running in a cloud where you have a bunch of other companies, large companies such as Netflix using the same resources, and we were experiencing some latency problems. There wasn't any guarantee on completion times of the jobs. And as I mentioned in the regional heat map, we want to make sure that we run 3 jobs every day, and we want to make sure that we finish jobs at a particular time before the users wake up in that particular region. And with Amazon, we weren't able to. And we also had latency problems when uploading and downloading data from S3. So what we did as a first stage of improvement, we used AWS Direct Connect, where they connect your data center to Amazon data center using fiber optic cables directly. It worked well, but then we still had some problems. So what we did, we actually implemented an in-house solution using Seamicro. This is how the box looks. It's really small. It's about 10 U in size. It has 256 nodes, which each have about 4 gigabytes of RAM and 2.4 gigahertz, I think, Atom processors. And in total, they have about 50 terabytes of storage, which is much more than that we ever need, because we do not keep all the historical data in this cluster. I'll go over in the next slides where we do that. And it also solved all of these problems. It is very energy efficient. It uses about 2.5 kilowatts per hour, which is one of the concerns we had. We didn't want to spend a lot of money on energy. So how does the model retraining work? So we have all these offline jobs which are running. However, when they're done, they will archive all of the data that they dealt with to data science teams Hadoop cluster. They have their own Hadoop cluster, and they will keep all of the historical data of all communication. Because once you create the match and deliver it based on the previous prediction, you want to use that as a fact to improve your future predictions, right? You want to see if that actually worked, if your prediction was correct or not. So we archive all of the data, and data science team uses that. They also use Scoop in order to download data from different sources, such as data warehousing, database, and others. And they use a lot of Cloudera technologies, such as Cloudera Impala, some Hadoop technologies, such as Hive, in order to come up with model retraining. And recently, they have redesigned the system to use Apache Spark because, excuse me, because they wanted to be able to do real-time retraining. And with Apache Spark, you're able to do that really nicely. So if you haven't looked into that technology, that's something you should definitely look into that. It's really performant. The way it's implemented is much better than MapReduce. So that's it for the affinity matching. The last portion is match distribution. And match distribution is basically ensuring that we deliver the right matches at the right time to as many people as possible across the entire network. And let me explain what I mean by that. Imagine you have these chatty people, Mr. Chatterbox, little Miss Chatterbox, and you have quiet people. So you might think, as a first thought, okay, let's just give those people as a match to each other. Because I know definitely, because both of them are chatty people, they'll talk to each other. However, as a result of that, you're affecting these guys, right? These wouldn't ever communicate with each other because both of them are quiet, very shy people. And so you as a product owner, you need to deliver a good product for everyone. So what we do, we use min cost max flow optimization solver, which is a graph solver. We have about a machine with 1 terabyte of RAM, and we use that in order to solve this huge graph. 1 terabyte of random access memory, it's pretty cool. And so we actually push all of the data there, and it comes up with an optimization for the overall communication of the people over the whole set of users. And if you're interested on the details of this, you can check out my link SlideShare, which is refreshed from LinkedIn. Some presentations which I did previously, which have more details about this specific step. So what is next? We have been creating matches between people. And as I said, eHarmony is all about creating happy relationships. Our motto is that we want to bring more happiness into this world. And so we are pretty successful, as the data shows, for past 15 years in creating matches between people. Now, besides being at home, where do you spend most of your time? You spend most of your time at your work. So our next product, which we will release in about 2 months, and I'm proud to say that I did most of the matching infrastructure design of this system, is matching between person and the job, matching between a person and the company. And that's essentially, if you think about it, matching between two people, right, or multiple people. You match the person to their future hiring manager. You match the person to all other members in their team. And we still do that. You have to know that this is not skill-based searching. This is matching. This is matching based on the compatibility of people, based on the personality or psychological factors of people, based on the culture of the company. So we do it on a deeper level. And so here are a couple of teasers from the product. 70% of Americans are unsatisfied in their current job. And as I said, we want to make this world a better place. We want to ensure that people are happy at their workplace, people are happy in their marriage, And we have a variety of other products which we'll release after this one, which are, again, ensuring that people are happier in their day-to-day life. So this is another teaser, and as you can see, it is matching based on the culture, and it's matching on a satisfaction level of predicting satisfaction level, not only skill-based. And we are going to compete with products such as LinkedIn, where they actually do only skill-based searching or matching between people. This is actually going to say, how happy are you going to be with this person, or how happy as a future employee will be at that company. So that's it for now. Thank you so much for your time, guys. And now I'm open for questions, if you have any. And I'll ask my friend Vazgen or Hafez to actually repeat the question.
Let me, I'll move notebook to the other side and disable the screen so you can see the crowd, and also I'll moderate the questions.
Okay, sounds good.
Okay?
Sure.
Okay, so do you see the crowd?
Yes, I do.
So so who has the questions? Raise hand, and let's start from Harut.
By the way, thanks for your presentation. How much hardware do you use for your Hadoop cluster?
Should I repeat the question?
Was it how much hardware do we use for our Hadoop?
Yes.
Okay, so do you mean the Hadoop cluster that we use on the matching engineering side for running the offline jobs, or the data science team?
Both of them, preferably.
Okay, so on our side, I don't know, can you guys see the slides now or not?
No. Okay.
Okay.
Wait a second.
Okay.
Okay, so on our side, on the matching engineering side, we have a different set of Seamicro clusters. We have actually 3 of them, which we use for different purposes. And the power of them is about 256 nodes, which have about 4 gigabytes of RAM each. And they have about 2.5 gigahertz Atom processors on them. And overall, they have about 50 terabytes of storage. And this is a presentation that I did previously, but currently we have cluster which is even more, about 3 times more powerful than this. So imagine about 1,000 nodes which can store much more data and which are much more powerful. And on the data science team, I think they are using just out-of-the-box hardware solutions, nothing specialized such as Seamicro, and they have about 80 nodes in the cluster, which in total can store, I think, 250 or 500 terabytes of data.
Are these nodes connected between each other using fiber optics, and that was the reason why you chose this in-house Seamicro?
Oh, so that's a good question. Seamicro itself, the way it's built, its architecture is done in such a way that the nodes are connected directly to each other. In this particular version, they're using a shared storage, which wasn't very performant. But in the newer versions, each node has its separate storage device, which works much better because there are not many I/O waits on writes. And there is actually a fiber optic connection between the clusters from Seamicro to the actual data science team's clusters, because we transfer a lot of data during the archiving stage. We want it to be very performant and stable.
How much does it cost?
So Seamicro clusters are, I think we got a very good deal recently because we have been their first customers from 7 years ago, I think. Their cost would be in hundreds of thousands of dollars, probably 250, 300,000, each of them.
Any other questions? Okay.
We saw the plot of the dependency between probabilities of communication and the distance, yeah? And we also saw that when the distance is about equal to the distance between two coasts, the probability a bit increases. My question is, doesn't that mean that there are just bigger cities in both coasts than in central parts of USA? I mean, will that also work, for example, for Europe?
That's a very good question. Yes, that definitely means that the east and west coast portions are more congested. There are bigger cities. There is a more people in those areas, and definitely, and I think they are more open. That's another factor that you have to consider, right? People living in the central part of United States are probably more conservative, and they want to only talk to people from their states, from the same political views. But on the east and west coast, most of the people I think are which are like more democratic, and they are more open to long distance relationships and things like that. So there is no one explanation. I think it's a combination of a lot of things. And you're right, definitely there are bigger cities in those areas.
Please.
Are you using Mongo for search only, or it's a database for you also?
Okay, so we actually use MongoDB for just performing the search. And MongoDB, in our case, I didn't mention that, but it doesn't act as a source of truth for us. It is just a data source that we can completely refresh from database at any point if something happens. It hasn't failed for us for 3 years, but in any case, if something happens, we can reconstruct the whole data from database. And MongoDB is used just for searches, and we have a caching layer even on top of Mongo, because we don't want to hit Mongo very hard. And there are some tricks done there in order to minimize the amount of queries we do. And the other portion, which I didn't mention to you guys during the Mongo slides, is that when we actually created this whole Mongo infrastructure and we're doing POC on that, we created a whole separate infrastructure which was able to shadow the existing infrastructure and not affect production users. So any traffic that was going through to production Oracle database was mimicked into the MongoDB cluster with the new software which we put on top of it. And we were able to tune it accordingly, the shard keys, indices, and other things for about 1.5 months without affecting the whole current production environment. Because when you have a product which is bringing about $1 million or a couple of $1 million per day, you can't risk of affecting the performance or correctness of such system. So if you guys ever decide to do some proof of concept of any system, my advice would be to create a shadow environment where you replicate your whole traffic through messaging systems or some other means, and then you tune it accordingly without affecting the real production environment.
I'm just curious, if you're using it for search only, did you consider Elasticsearch? If yes, why did you choose the Mongo over Elastic?
Yes.
That does things in a better manner.
Yeah, we did actually. I forgot to mention, but during the proof of concept, we actually dealt with Elasticsearch. We did POC of that. We also did a POC of Solar, which is another engine optimized for search. But MongoDB, as I mentioned, is very easy to maintain. It doesn't need a very deep knowledge about the inside, and it was very well supported. It has a good community support, so it just worked for us. And we didn't have a need to use Elasticsearch for that particular case. And you have to also know that when we actually did a POC for that 4 years ago, Elasticsearch wasn't as good as it is now. And currently, we are using Elasticsearch in a variety of other products. And so we're very open in using different data stores, NoSQL solutions, depending on a product. We're not just tied to one.
Please.
Hi, David. I was interested, what are the channels that you use to evaluate your training models, and taking that, and how you use that, the data out of that evaluation? Do you kind of circulate it back into the training model, or would you describe that a little bit?
Vazgen, can you please repeat the question? I couldn't hear it very well.
I wanted to know, what are the channels that you use to evaluate your training models? You have like various kinds of training models for example, matchmaking. So what are the channels that you use to evaluate them? And then if you do so, how you use that data? Do you circulate it back into the model, or you use it probably somehow other way?
Yep.
So
sure, I will definitely. So as I said, we have machine learn team which is coming up with model definitions, right? They are giving us a variety of model definitions which might work for a particular case, might not work for a different case, and they're constantly retraining them. So the channels that we use in order to test them is through just A/B testing. We have a notion of test groups where we say 1% of users will get this particular model, and we trace it, we compare it with the base case, and we'll see how well it performs for a prolonged period of time, let's say for a week or 2 weeks. Because depending on the day of the week, let's say people are more communicative during Saturday and Sunday because they're at home. People are less communicative, I guess, on Monday and Tuesdays. And so we run it for a prolonged period of time in an A/B testing mode, and we determine if the new model is good enough or not. And of course, any type of prediction that we do, we as I said, we run offline models, right? We create matches, and then at the same time, we have a system which is getting real-time communication information about the matches that we created. With that approach, we're able to correlate the match that we created and the future communication that that specific match with that model triggered, and basically be able to say if it's going to work or not for a prolonged period of time. But so besides offline matching system where we archive the data to data science team, all of our real-time matching systems are also archiving the data to the data science cluster. So they have a trace of everything that is happening, and they're using that in order to improve their models.
Okay, thank you.
Okay, any other questions, please?
Okay, so are you using caching during the merge process, like for some demanded groups, like Fedans, UI guys, etc., or you are retrieving the same data every time?
So how we're using what?
Caching mechanism. Like there are some groups that have demanded more, like blue, white boys or Fedans, so you can cache them, not to retrieve the data every time. So are you using that, or every time getting it from database?
Okay, so that's a good question. Let's see. If we go back to this slide, I don't know if you can see it or not. Okay, here. So we use a service called user service, which contains all of the data about the user, and it is acting kind of a cache. So we use Voldemort to we have a system which is called user service, which aggregates all the information from different sources, including database, and it stores that in here. Because Voldemort has a notion of in-memory database, and if you have enough memory provisioning on your hardware, then everything will be in random access memory. So it is acting as a cache, as a result of which we're getting around 5 milliseconds of response. But we also have caching solutions in front of MongoDB and some other places. So we definitely leverage caching wherever we can. We also use Google Guava caching. I don't know if you guys have used that or not. Inside the applications to cache specific portions of the data. We use eHcache in some portions to act as a caching solution in top of the database. We also use Redis as a caching solution. So we use a variety of systems depending on which portion it is dealing with. And we're also pretty open in that aspect. Like if some team wants to use Redis and then some other teams wants to use Memcache, if they have a good reason for that, for the use case, they are free and open to use that. There is no enforcement from top. Anything else, guys?
Okay, so the last question again, Harold. So last question.
As far as I've heard, you use some psychological models to match your person, like match people in your database. Why don't you use machine learning to see which type of people naturally match each other, like rather to filter the results based on model and base your matching not on the psychological thing, which is which cannot be like completely unbiased, you know. We match it against some psychologists to design some model. They also can be wrong. We can train some more smarter method of matching using machine learning, right? We can see which type of people match better, collecting some feedback, and train that model instead. Why didn't you go that way?
So that's a very good question, and I think that's the basis of eHarmony. We use machine learning models to predict communication because that's what we can do. But I don't think there is a very easy way to be able to define psychological profile of a user with machine learning models. I think there are probably some studies going on in that sphere, but I don't think that sphere is mature enough to be able to use in such a case. In our new products, we are trying to do something like that, but we haven't succeeded yet. It works much better if the actual main compatibility engine is designed and reviewed by people and not machine learning algorithms. So I think it's just, it's a thought that we have in mind, but it hasn't proved to be working yet. And it's very difficult. I mean, I'm not a psychologist. I can't tell why it doesn't work, but I know that they have done some attempts in doing that, and it's not proving to be insightful yet. Anything else, guys? Hello? Hello?
Hello. So thank you very, very much for this awesome presentation. It was really great. So
Thank you.
We will in our Facebook group, in our Facebook event, and stay tuned to our next event. We'll probably have it in 2 weeks. We are targeting now different speakers. Probably it will be one from the VMware, and probably maybe we'll have some guys from Twitter talking about their infrastructure and their using of big data. Thank you very much for coming. It was great.